didn't. I didn't make the time last night. I
Yeah,
didn't.
this
I
was,
was
this was
caught up in a Kegel
so-
contest that
maybe
someone
help
had
me
it.
write a better-
It was just showing us. They were trying to show us what
better,
Kegel. We had a
program.
data set and we were seeing if we could work on it, and it was
It
had a lot of
writes many
people there.
batches, and then it will kind of do the.
This will try
Mhm.
current job data into different batches. So,
Uh-huh.
yeah, I guess it won't be memory flooded.
Then it does it, okay.
Alright, so let's start the last lecture of the semester. And today's only going to be 1 hour, unfortunately. I should have announced that, but I have to leave early because I'm flying to Boston today. So let's talk about this paper. So does anybody have like questions, comments, ideas about this paper? So what was most remarkable about this?
As far as I understand, you don't have to pre-process. You send raw data, you just normalize it for the loudness, and it does the whole thing, because I think the pre-processing part was always a bit larger for voice.
Yeah, exactly. So let's write that down. So where is it? And I think I'll send this around like later on, like what made your features so successful? Or is it?
Could you make it a little bigger?
Yes.
Thank you. Oh, there it goes.
Okay, so first, like, no feature extraction. And so these models are have a certain name. So nowadays, like a lot of people are actually using that. This is called like end-to-end neural modeling. So like. And so basically what that does, or what that means, is that you're giving basically a raw signal or close to raw signal as input, then the neural network does its stuff, and there's an output. So, and you train this also like from the loss that you create at the output all the way to the input where you get the raw features as input in one go. So that's kind of one of the newest kind of like ways to do these things. So couple of things that are important here are, like, what would you say is important in this context? I think one of the most important things here that needs to be like remembered, I feel like remembered strongly at that actually, is that that makes your neural network approach completely black box. Like, you have no clue what it does unless you're like really looking into it and like trying to understand every single tiny bit that's going on. Did the paper do that? Like, try to understand what's going on? They did a little bit. We're gonna get to that later on. Like it's like the figure 2, I think, where you have these lines where they look at like are typical raw features like correlated with some activations of neural outputs. But I'm skeptical what they did there. Okay. The other thing that is important for these end-to-end models, like, what do you think? I think very important, like, depending on the size of your neural network that you're training, you need to have a lot of data if you want to do that. So feature extraction is very useful in times where you don't have a lot of data and you know what you're looking for. So you're extracting the important characteristics of the signal already, which means you're taking like large dimensional inputs such as like a second of audio could have like 16,000 observations, right? And so, but not all of these 16,000 observations are meaningful. Like there might be some noise in there, not all the time the person is speaking, and so you want to reduce this information to maybe, let's say, 20 features or something like that. So, and here is also the crux of what they're doing, by the way. One of the things that you should keep in mind, and is the camera rolling?
No, go ahead.
No, don't.
No,